Sea level's been rising pretty consistently for about a century or so. This is a graph since 1850. The global average sea level, not here, you're worse here, but the global average sea level has risen about 8 to 10 inches over the last century or so. The line's pretty stable. If you could buy that stock, you'd want to buy it, right? It wouldn't matter that it bubbled up and down along the way. The fact is, we like to see the trend of things, and the trend here is not only an increase, but it's steepening. And that's been known for decades. If we look at that same amount since 1880 and put it as the red wavy line, that's that 8 to 10 inches, comparing that to a dozen US cities from New Orleans on the left to Galveston to Virginia Beach, not too far from here, to Miami, New York, and on down to Los Angeles, we see that the height of sea level since 1880 has varied between 46 inches in New Orleans and 4 inches in Los Angeles. And yet, intuitively, we think that sea level will be the same everywhere, right? Well, the difference is that land moves up or down, it subsides or uplifts. And when sea level's moving fractions of an inch a year, and the land's moving fractions of an inch a year, it either adds to or subtracts from. California, the plate's going underneath California, which is why you get all the earthquakes out there. So that's why California's been lifted up. New Orleans is sinking because it's silt from the Mississippi, and we take petroleum and water out of the ground, and so the ground collapses. Virginia Beach is number 3 on the list because partly the same reason you have more sea level here, sea level rise here, which is that there's plate tectonics, that the plate that goes from North Carolina to the northern, up to Canada basically, or northern New York, is tilting basically. On top of that, there was a meteor that hit 35 million years ago off of Virginia Beach area, Hampton Roads, and that's causing a further compaction. The ground adjusts slowly to big change. Okay, and normally we wouldn't notice it, but with sea level, it can exacerbate the situation significantly from place to place. Now we think of floods like Hurricane Isabel, right? I mean, a couple of photos here of Annapolis. I've done some work for, where's Lisa? There, with Annapolis, with historic preservation. And Annapolis is fortunate because it has the density to approach this in a way perhaps the Eastern Shore is different, but different than a Baltimore, New York City, or Miami. So different places have different opportunities and different cultures and different densities that will make a difference as to what they can do. But besides even a hurricane, there's routine flooding in Annapolis. It's hard to tell where the parking lot and the canal end there. But out here, I think this was from Chestertown area, as I recall, but there's frequent flooding. You see that, right? We tend to confuse it with events like Hurricane Superstorm Sandy, which breached the shoreline, but that was a storm event. That's entirely different, actually. So one of the things I want to help you do is to separate beach erosion from the kinds of unusual flooding. Anybody know where this is from? Venice, Italy. So when I was there as a kid in 1959, I hate to say, but that didn't used to happen. St. Mark's Square didn't flood. Now they keep the bleachers and, what do you call them, catwalks out because they get about 100 days a year when you need either wading boots or to stand on top of stanchions to get through St. Mark's Square. Something's changed. Now, Venice is sinking, so a little bit like here in New Orleans, it's worse than the global average, but things have changed. San Francisco, the Embarcadero, water comes over the seawall. That seawall height was established 140 years ago. It didn't used to happen. And that's not an ocean wave. Remember, you got to go through the Golden Gate Bridge and behind Alcatraz Island before you get down to the Embarcadero, the 7.5-mile waterfront. And every 28 days with the full moon high tide, water's coming over the seawall there. And they're asking how high should they build after 140 years to reestablish the height of the Embarcadero. And yet be cognizant of the fact that that waterfront is part of San Francisco's identity and tourism. It's no longer a working port. That's moved over to Oakland. But all over the Bay Area, they have similar problems to the Chesapeake Bay. If you think about it on the east and west shore, that these two big estuaries have a lot of similarity, really, in terms of scale, and from rural to cities. You probably remember this, I think it was on the front page of the Baltimore Sun 5 years ago. It was the last house on Holland Island to go underwater. It's in my book, actually, but it was from Sharps Island, went underwater 50 years before that. And you've had a trend here of islands disappearing from erosion, subsidence, sea level rise, a variety of causes. If we think of flooding, we don't usually think of it this way, but if you want to think of flooding, there's different kinds of flooding. There's some sea level rise, there's storms and heavy rainfall events, which are, storm erosion, and then heavy rainfall. Topographic forcings where water gets into a waterway, whether it be the Chesapeake or Narragansett or Florida or New York Harbor, and when there's a surge, it piles up higher, and it's amplified, if you will. There's extreme high tides, which we'll talk about. Subsidence, I already mentioned. Runoff and downstream effects are where rainfall, et cetera, goes somewhere else and again amplifies. It can be even in a flat town like Miami, or it can be up in Vermont and New Hampshire where water moves downhill to worse effect. That's all flooding. And then there's erosion. I put that in brackets because it's really not of the same nature as the other thing. Erosion creates problems typically because of wave scouring or interrupting the flow of sand along a beach by a jetty or something like that, but it really is an entirely different character than the flooding forms. So what do we know about sea level in the big picture? Because that helps to see why things are changing now. Since the last ice age, about 20,000 years ago, which is the era when the Chesapeake and actually these areas were all formed. I mean, the Great Lakes were formed from the last ice age, less than 20,000 years ago. We take it as a permanent part of the topography. But features like the Chesapeake and the Great Lakes are less than 20,000 years old. They were scoured out by the glaciers and ice sheets 2 miles thick. And as those ice sheets melted, sea level rose about 400 feet, according to this rough diagram. And what's interesting to note is that it got to the present level roughly about 5,000 or 6,000 years ago, which is pretty much our human civilization. And we have trouble believing it's going to be much different. But not only has it been there for a long time, a few other really interesting takeaways from what would seem to be a simple diagram. It didn't rise smoothly. You'll notice there's 3 steps along the way. That's how the glaciers and ice sheets of Antarctica and Greenland collapse. That's how they will collapse. Sea level, as I'm going to show you in a minute, is not going to follow the smooth curves that typically the engineering and science publications put out there for us. That's not what's going to happen. We're going to hit a bump, a bad one. It's going to go upward. We just don't know whether it's 50 years from now or 150 years from now. So we need to plan different. And there's an opportunity to do better planning that's different from preparing for the next storm or the next heavy rainfall event, etc. I'll show you in a minute that the other interesting thing is that the reason sea level had stabilized for 5,000 years is because it was about to turn downward by nature. If it followed the ice age cycles, as I'll show you, we were at the plateau phase, which is kind of like the slack tide. You know, if you go up to an inlet and the water's coming in, and if you just showed up there at high tide, you just see some water swirling around and you wouldn't think the height changed for 20 minutes, right? But then for the next 3 hours, it would start going down. Well, we showed up here at slack tide. It was a 5,000 year slack tide. And the water would have started going down, but we've changed that now. That all happened because of something called the Ice Ages. And I'm sure you saw the Ice Age, the scientific series, part 2. My daughter was 6 at the time that part 2 came out. This was the meltdown. And I love this. I mean, I watched this 30 or 40 times. Behind Manny, Diego, Sid, and Scat, you all remember that, right? There's 10,000 feet of ice, 2 miles of ice. And as that melted, the ocean rose 400 feet. That's about all the science you need to understand to prove why sea levels change dramatically. And it's just that simple. And it actually was a reasonably accurate cartoon and kind of fun. But let's come back to reality. We know by this NASA image, by the best estimates of the last century compared to what's happening now, this shows global temperature change for 5 years, 2011 to 15, compared to the prior century. And the legend at the bottom says that the red is 2 degrees Celsius, which is 3.6 Fahrenheit, 3.5 degrees Fahrenheit, above normal. Normal being the last century. And the problem is that the heavy heating is in the Arctic. It's not here, actually. I mean, you're seeing some weather changes here. But the big problem is that the big temperature change, because of the tilt of the Earth and the placement of the continents, and some currents from the equatorial regions, etc., puts most of the heat in the Arctic, pretty far from us. You're probably all familiar with the Paris Climate Accord, which the current administration is threatening to pull us out of. And I stay out of political debate, but I will call out a couple of things for you. The Paris Climate Agreement, which goes back to December 2015, this is a simple graphic put out by a group called the Climate Scoreboard, or Climate Interactive, based at MIT. And what it says is in green there that the goal that's been pretty well agreed in the scientific community is we should try and keep the warming to 2 degrees Celsius, or let's keep it in Fahrenheit, 3.6 Fahrenheit, over what it was before the industrial era when we started burning fossil fuels. So we've already warmed about 1.5 degrees Fahrenheit. That would say allowing for another 2 degrees Fahrenheit above the current. Okay? And their best calculation is that if we don't do anything different, we're going to reach 8 degrees, another 6.5 degrees above the current. Okay, it's a global average. And that if we implement all the policies that are currently on the table, which again the current administration is saying they want to back off from, we will reduce the warming by about 1.5 degrees. Substantial, but doesn't get us near the goal. Let's go to the Arctic. The area around the North Pole, which we think of as polar bear territory, is melting. You all know that. How many of you would associate the melting of the Arctic with sea level rise? Okay, most of you. So this is April Fool's Day. This is not an April Fool's joke, but that has nothing to do with sea level rise. Because if you took a glass at home with anything you want in it, like to drink, and had ice cubes in it, you can run this experiment at home. The melting of the ice cubes will have no effect on the level of liquid. You have to add an ice cube, drink water, or pour more water in the glass. That's the only way to change the level of liquid. Okay. And most people tend to think that this is why sea level's rising, but this is floating sea ice. The problem so the icebergs and things like that we visualize have no effect. It's the ice on land, whether it be Alaska, whether it be the Alps, whether it be Peru, but primarily Greenland and Antarctica. That holds 98% of the ice that's on land. So the truth is, everything else is small stuff. We really have to understand what's happening in those two places. And as glaciers move to the sea and break off into icebergs, as meltwater from land goes to the ocean, that affects sea level. The other factor is that the oceans warm, they slightly expand at a minuscule amount, we call thermal expansion of seawater. Those are the changes to sea level. It has nothing to do with the floating ice. Sea level has changed over millennia and over eons of time with what we call the ice age. And I keep mentioning the ice age, but I'm going to bring you into that gradually here. Repetition really does help to plant new thoughts. Sea level has moved up and down with the ice ages for millions of years. Here's 400,000 years to begin to see the pattern. The pattern is a pretty regular pattern. If we lay on top of that sea level global average temperature and carbon dioxide, a greenhouse gas, an amazing picture emerges. And I'm going to tell you how to get this graph and use it for free at the end of my talk, by the way. Follow the red line. We've had 4 ice age cycles roughly every 100,000 years. It's by something I explained in the book called the Milankovitch cycle. It was discovered in 1938. It basically just explains how the change in the elliptical shape of the orbit around the sun, the tilt and the wobble of the Earth, those 3 things line up or combine between 95 and 125,000 years, so we'll call it 100,000 roughly. And it becomes like a giant summer and winter. It changes the amount of solar energy we receive. And that's an ice age. That's what triggers it. Natural cycle. And so if you follow that, we've had a natural ice age cycle, high, warm and cool, 5 degrees Celsius or 9 Fahrenheit is the global difference every 100,000 years, and we're at pretty much the warm spot. And as the planet warms or cools, the ice sheets change over thousands of years, and sea level changes. So you get why the red and blue lines correlate, right? And the green and red lines correlate because back in 1859, an English scientist named John Tyndall identified that carbon dioxide acted like a greenhouse gas. He didn't call it that. He just identified trapped heat, confirming something he discovered in 1827, that the atmosphere really determined the temperature of the planet, the composition of the atmosphere. And I just wrote a blog post, in fact, a few weeks ago, and I'll tell you how to get to my blogs at the end of this. It's for free, and I don't do anything with the list, but I wrote a blog post 2 weeks ago that Alexander Graham Bell, 100 years ago, in 1917, I mean really a century ago exactly, he described for the first time in America the greenhouse effect. And he expressed concern that if we kept burning fossil fuels, we would warm the planet. And he admonished us that we should go to solar energy as soon as possible. 100 years ago. So, when the director of the Environmental Protection Agency says the science isn't settled that greenhouse gases are related to temperature change or climate change, that's nonsense. Absolute rubbish. No politics involved, but that's just, and I don't take on politicians, but I wrote a blog about him 2 weeks ago, that he's got his head in the sand or somewhere else, I said. It's been proven for 180 years that carbon dioxide traps heat. And we know the problem is that in the far upper right-hand corner of this chart, it's that vertical green line that carbon dioxide has gone out of the range of 180 to 280, and it's now at 400 parts per million, as some of you know, and it's heading straight up. And groups like 350.org think we should find ways to get it down to 350 at the highest, and Citizens Climate Lobby and probably groups that some of you are involved with are all saying we really need to get our atmosphere back under control, because with carbon dioxide goes temperature, with temperature goes sea level. But it's a slow correlation. And it's actually to the point where even if we stop this, we're not going to immediately stop this. So they become somewhat disconnected. There's a connection, and we must do both. But we must not think that solar energy is the answer to sea level rise. Okay, and that's disturbing, but it's just fact. We know that information. People say, how could you possibly know what temperatures were and carbon dioxide levels? Well, fortunately, for about 20 years, we've had a really great technology in Greenland and Antarctica. We can drill down, just like you go into a tree and get tree rings and get some information about what happened during the life of the tree by what's happened in the layers. Well, we get them horizontally. The layers of snow and ice, or snow which gets compacted into ice, and the air molecules which are in between the snow crystals. And as the snow turns to ice and then under weight becomes pressurized, within that person's fingers is about a year of snowfall that's been compacted into that much ice. And the bright spots are air bubbles, and they're pressurized. And if you put them in water, they'll hiss because they actually are higher pressure because of the compaction. And we go into those air bubbles and we can measure carbon dioxide. And we have a 140,000 year record in Greenland and an 800,000 year record in Antarctica. And temperature is a little more magical to come up with, but it's really simple. And it's, again, simple physics. Undeniable, unarguable for anybody who wants to look. There's two isotopes of oxygen, 16 and 18. And they change in ratio based on temperature. So if we get the ratio of the oxygen molecules, the isotopes, in those air bubbles going back 800,000 years, we have a relative proxy for temperature change. And it correlates, it's not just US scientists and people trying to get grant money and stuff that gets alleged. This is being done by dozens of universities, by not a dozen, but at least 8 different countries, from China, Russia, Japan, Canada, etc., Denmark for sure, that have each done their studies, and they compare results, and the results are similar. So it's impossible that anybody would make that fraudulently. I mean, you couldn't get grad students from 100 universities saying, okay, we're all going to make this up and do it together and keep quiet about it. I mean, that's just not possible, right? This is really good data. And it's leading edge stuff. The technology didn't exist 20 years ago. So, what's the problem with sea level rise? The problem is these 2 places, Greenland and Antarctica. There's enough ice on Greenland to raise sea level 24 feet. There's enough ice on Antarctica to raise sea level 186 feet. All the other glaciers from Alaska to the Alps, etc., another 2 feet. And, you know, then there's the thermal expansion of seawater. But you can see that 98% of the problem is in front of you. So everything else is frankly a distraction. Greenland is really hard to keep in perspective. I've been there now many times, I guess a half dozen. And most recently I took the Assistant Secretary of the Air Force. They're concerned, we have an air base at the north end of Greenland, there on the right. I took the Commandant of the Coast Guard there, with Senator King from Maine last August. It's so big, it's hard to comprehend. And I finally came up with a way that's so simple, I don't know why I didn't think of it before. But just compare it to the eastern United States. It's 1,600 miles north-south and 1,000 miles east-west. You know, when you see it on the map, you assume it's a distortion of, you know, how things at the poles get distorted when you lay them out flat. It's that, but it's also just incredibly big. It's about the same size as the eastern United States. And it's covered by 2 miles of ice. But we tend to forget about it. Except that it's up there in that red zone where things are warmer than ever, right? And it's melting. A couple of quick shots flying in last August. When I was there a decade before, this area was covered by snow. It's now part that's exposed. The ice sheet has retreated. What's disturbing is, this is a photo I took, and that's a glacier on the right-hand 2/3 of this picture. You can't see it too quickly because you expect glaciers to be white. This one is dark gray, and it's part of the reason this is all starting to spiral out of control is as the glacier melts, the ground is being exposed, but under the thousands of feet of ice, the rock's been ground into dust. And with strong winds, which happen up there because of the thermal changes, the dust blows up on the glacier and turns the glacier dark, and that accelerates the warming. So as the Arctic Ocean goes from bright white to dark ocean, the effect is, you've probably heard about the positive feedback loops or snowballing effect, etc. That one thing, it builds upon itself. It makes it worse. So as the glacier recedes, this fine dust is blowing up on the glacier, which is like taking a white roofed house and painting it dark gray. Your heating bill's going to change, right? Okay, you get that. The glacier breaks off into icebergs. If you go to the top of the ice sheet, which is really a flat, the Greenland's covered by one ice sheet, 80% of the island, that drains by glaciers and breaks off into icebergs, which you can think of as giant ice cubes. How are we doing on time? Let's see here. I think there's a short video the Coast Guard did that I'll give you a link to later. But let's go to Antarctica briefly, where I was in mid-February with a big corporate group. We were trying to get to the Larsen Sea ice shelf. You probably saw that in the news, that there's an area, and that piece is supposed to break off sometime soon. This crack is about 120 miles long, and with another 12 miles, I think it is, it's going to separate, and it's the size of Delaware. Read about that, that's probably not new news, but we were trying to go see that, but couldn't get close to it because there's so much ice in the water, it wasn't safe. So we went around the other side of the peninsula. But that's not going to affect sea level directly because again, it's floating sea ice. Antarctica is much bigger than Greenland, 7 times the amount of ice mass. The problem in Antarctica, let me decode Antarctica for you for a minute because it's confusing because it's normally white. This is a colorized picture showing movement of ice. The right 2/3 of Antarctica is East Antarctica. It's actually getting a little thicker because of snowfall. It's also getting a lot more sea ice out here, but that has nothing to do with sea level rise. The problems in Antarctica are the shelves, this big one, this one, and then the Larsen shelf that we just looked at up here. There's West Antarctica and the peninsula. So we've got East Antarctica west, the shelves, and the peninsula, four parts of Antarctica to keep straight. The problem, the ice shelves are not that huge a problem by themselves because they're floating sea ice, but they're holding back the glaciers on land. They act like a stopper in a bottle because they're full of bay, okay? And once that ice disintegrates, then the ice on land is more inclined to come in, to slide into the ocean, right? Does that make sense? So, but the problem in Antarctica is this area that's in red here, the 8 o'clock position. We looked at that same area from an aerial view. There's 6 glaciers there that we call the Pine Island glaciers. And again, this is described in my book, thank you, that they hold 10 feet of sea level rise. And we just don't know when they're going to slide in the ocean. But by gravity, they're poised to do that. And it's the reason that most of the projections have a wide range of uncertainty. We can't predict that any better. We can predict an earthquake any better than we can predict an avalanche or a tsunami. We can't predict those geophysical collapse events. And it's disturbing, but it's not a matter that scientists are incompetent or we'll get the science better. We'll get the science better, but we'll never be able to predict sea level rise that accurately because we can't predict how those ice sheets are going to slide. So to kind of recap and end this, storms, extreme tides, and sea level rise are different. Sea level have different effects in different places. Sea level projections differ and will change. What I say, the simplest way to put this is, we should start planning for the first 3 feet of sea level rise as soon as possible. It doesn't mean tomorrow, but it means we can't keep putting it off because it becomes harder, which is really the nature of this talk today. That whether it be emergency management, whether it be the energy side of this, which to slow the warming, we need to think on a different time scale. Not just for us and what's going to happen in the next 10 years, because sea level rise isn't going to be too bad in the next 10 years. But the fact that it's going to get a lot worse mid-century is inevitable. And certainly the latter part of the century. And like most of you, I mean, my daughter's one of these 2 kids on the beach a few years ago. This is a profound concept. It's not the end of the world, but the world is changing. And we've got to find ways to both educate ourselves, which all of you out here on a nice Saturday morning are obviously doing, and you're obviously leaders in your community, and it's great that the Eastern Land Conservancy here and the supporting groups are educating and helping to make others aware, which is really what needs to happen. But these concerns, I think you'll agree, are probably different than we even thought about 20 years ago. Nobody thought you could melt the ice this quickly. The latest NOAA projection, I think I'm really at the end of my time, so I'll be quick, says we could have up to 2.5 meters this century. But the truth is, those 5 curves for sea level rise, sea level's not going to follow those curves because it always goes in steps. And we don't know which curve it's going to follow. Here's the latest projections from the state of Maryland, actually 2013. Worth noting for a second here, they do it 2050 and by 2100, and they do the lowest estimate, the best estimate, and the highest. I take it's good, but I take some exception to it for this reason. If by 2050 the highest is a foot or 2, that's fair for planning purpose. That's still a lot. The problem is later in the century. To say that 3.7 feet, which is what's on the state's website, that's really misleading. Because when you say 3.7 feet, which is just an average of several numbers, it implies it's going to be 3.7 feet, right? I'd rather they said it's going to be between 3 and 6. Because that's the uncertainty. In fact, now it'll be between 3 and 8 because that was that new latest study. So we've got to frame this, we've got to explain it differently. It's not a political statement, it's not just an emotional statement. We've got to really think about reality differently. Is there any good news? And what can we do about it? And then I guess take questions. This is almost a philosophical question, if you will. It's our relationship with the earth. It's different than what we thought. You can see that. It's different than the other issues of erosion and storms and so on. Rainfall, flooding. It's an opportunity to teach and to learn. The fact is sea level moved up and down 300 or 400 feet without us. We were ignorant of that. So as most very smart people said, we can learn from nature. Sea level was changing anyway. We got fooled. It was a big April Fool's joke, right? That we shut up here at the point of stable sea level after 20,000 years of rise and when it was going to enter 80,000 years of fall. But we've changed things. And it's because of our energy policy or production, as Alexander Graham Bell warned 100 years ago. And we do need to change how we produce energy and all the other issues related to that. But we've also got to wake up to the reality that the polar regions of this planet determine our sea level here in the Eastern Shore. And what's exciting is to take a group of concerned citizens and thoughtfully say, how do we begin to plan for a new reality which is not like a storm which can hit us next week and destroy us, like a Hurricane Sandy, which would be devastating, but is slow and inexorable and now unstoppable. We can slow it if we do the right energy things, but even if we do all the right energy things, we're still going to get sea level rise. So people say, that's depressing. I said, well, no, getting older is depressing. And besides making you laugh purposefully at the end, there's also a lesson in it. Any of us could have died at any age in our lives, by disease, car accident, or anything else. We know that, right? But we learn from life, we enjoy it, we prepare for our successors intelligently, we try and eat well, diet, whatever, exercise. We need to do the right things, but we don't know what's going to befall us. Okay. But interestingly here, if we do the right things, we can make the future better. We may not know exactly how quickly, and it may disturb our land values and our planning for streets and our emergency services, but we can adapt to this. And if we don't learn from nature and learn from what's happening around us, shame on us. We're starting something called the International Sea Level Institute. If any of you are interested, I'll tell you about that later. I don't want to take up time here. It's to do more with this. So it's not just me running around explaining this to Coast Guards and corporations and architects in Florida next week. And a privilege to be here. I was at the Chesapeake Bay Foundation. Is Willie here? Right? But you all here are very concerned about the environment, concerned about your natural setting. You see flooding every 28 days with high tide. And there's a lot to learn, a lot to share, a lot to educate others. So thank you, and I'll take a few questions.